Right, I thought what I'd do today is talk a bit about shell scripts. And this is inspired a bit by helping out with the training course we give yesterday. And I think the course is very good, but it teaches a view of the world where a job script that you submit to the batch scheduler is kind of a fill out the form type exercise, which is fine. It gets researchers to where they want to be, but I really want to talk a bit more about how things work and why they work, and maybe unveil some of the madness therein. So let's work out. I get to the next slide because my mouse is on the wrong screen. Right, so what is the shell, right? So when we talk about the shell, what we mean is it is the command line program that when we interact with it, receives our commands, does our bidding or says no, and gives us our output, right? On Linux, particularly on our HPC systems, the default shell is a thing called bash. If you have a Mac, Macs have had different default shells over the lifetime of Mac OS. For a while it was a thing called TC shell, then I think it was bash, and now I believe it's Z shell. On Windows, you'll be using either command or PowerShell, right? There are lots of others that exist. I particularly like Fish, and so I use it on my laptop. That's the top of those two windows there. But you should be familiar with bash because it's the most common pretty much everywhere where you're going to use a shell. So if the shell is a thing that takes your commands, right, and does your bidding, then how do you automate that? So the answer is very simple. You put your commands in a text file. And then you make that text file executable. If you're on Unix, you have to do that by adding the execute permission bit to it. If you're on Windows, you end it in .bat, and then it is treated like a batch file. The behaviors of these are quite different. Generally, when you run a shell script on Linux, it will create a new process that script runs in. That can be controlled by a part of the shell script called the Shebang, which I'll talk about in the next slide. On Windows, the equivalent, a batch file, runs in the current instance of cmd, right? And we can kind of prove that by setting a variable and imprinting it, right? I don't want to get started on PowerShell because it's a bit of a pain. So, the Shebang. The Shebang is the first line of the shell script. It has this very odd construct here which starts with a hash, and it starts with a hash because the hash means a comment. So when the script is actually given to the shell, it will be ignored. An exclamation mark, or the bang, and then the path to the shell, like where that interpreter actually lives, that you want to run the script with. The Shebang must be on the first line. Right, so I'm going to show now is on Linux what a shell script looks like running it, and I'll show on Windows as well using a batch file. So here we are, we're in Myriad. Let's create a text file, so we'll call it test.sh. The .sh is not required, it's just kind of for my information when I look at files, and we should just put in some commands that we'd run on the command line. So I don't know, let's do ls -alh ps xjf and echo hello, right? And if we run that, well, first we have to make it executable. If we run it, it runs, right? It does those commands in sequence. We get the output on the terminal. If you look here, when we've done psxjf, it's actually shown us. So this is our original shell, the bin bash, and this is the shell that's running the script, right? Right, next on our list. But we want to have that shebang in, right? How does this behavior change if we put in the shebang? So let's edit that file and put in the shebang. And now if we run it, we'll see that it has run. It actually specifically done something slightly different, right? It started a new copy of bash explicitly and run the test.sh script, right? This is important because you could give it a different shell, right? You could tell it you wanted the script to be run with C shell because it contains C shell commands, and they would not work if you tried to run them on bash. Good, right, so that's Unix. Windows, let's switch over to Windows. Right. So here we have a simple script. The so one of the ways in which behavior differs on Windows is that by default, as well as doing the commands, it types out the commands on the terminal so you can see what it's doing. You can stop this by putting @echo off at the start of your batch file. So let's do that. So if we run, it runs the commands as we expect. There is a considerable difference here, which is this is exactly the same shell as the copy of cmd that we're typing into. And we can prove this by setting a variable in our script, right? I think I've done this earlier, so this is probably not going to do quite what I want it to do, but let's just check this. Oops. No, I've not done it. Excellent. So if we look at what's in the script variables.sh, sorry, it sets ontest to hello, right? If we run that, and then we print out ontest, it's set to hello, right? So it's happening in this shell. If we do this on Unix, on the other hand, right, I believe I've actually already written this. Yeah, if we show var test, right, it's doing export, it's exporting the variable. Export means all the subshells will inherit it. But if we actually run that, and then we do echo, it remains empty, right? It's not been set. We can actually deliberately execute that in the current shell by using a command called source, or there's a shortcut for it called dot. So if we do dot space dot/var test, or I almost never use the dot syntax because it's a bit difficult to see sometimes in your editor, I just do source. And now if we echo that variable, it's set, right? So you can execute stuff in the current shell, but you need to use source to do it. So obviously this doesn't just apply to bash, right? You can use it for other languages like Perl or Python by putting their interpreter in the shebang instead of bash or C shell or whatever. It's a really nice way to make your script executable without people having to work out what to run it with. And there's another nice workaround here, which is sometimes things like Python are installed in a weird path, so you don't want to give the exact path to Python. But again, there's a nice workaround. There's a thing called userbin env, which if you say userbin env and then the name of the interpreter, it will pick the first one in the path, right? So if you load like a newer version of Python from modules, or you have Anaconda set up and you have your own modern Python or whatever in there, you can do that, right? And I'm going to prove that works. So here I have some other scripts. So if we look at the Python script in here, right, I've put in the full path to the interpreter there. So we could run it like that. You'll note that it is I have made this executable, right? But I could just as easily do that, and it still works, right? It picks the right Python. Okay. Any interpreter will do, right? Anything that will accept a command line argument with the name of the file and is happy to ignore the lines that start with the hash. So, as an exercise, I have a small suite of programs written in Fortran that do little things to input they get from standard in. There's one that sums up integers, one that sums up doubles, one that does a mean of doubles, one that does the max of doubles. I thought, well, I'll tell you what, it will be a half-hour exercise over lunch. I will make these programs work as interpreters for a shell. So I had to make some changes. I had to put in some code to get the command line arguments, because I didn't have that before. And I had to slightly change the behavior, so it just skips over things which are not numbers. But yes, I've made this little program which sums up numbers normally, right? Act like a shell interpreter, and you can write shell scripts in it. So here we are, right? Normally, if I run int sum, I do something like this. Right, it sums up and prints out the output. Or I pipe something through, like a typical one might be, what's the output of node types look like? Yeah, so if you get that first column, right? That tells us how many nodes we have up currently. So I wanted it to take a file, so I had to slightly change the way it reads in, so you can give it a command, you can give it an input file now. But we can write a shell script. So, and I've done that. So if we run, we get 42. What does that script look like? Well, it has a shebang, right, which invokes the intsum program. It has some numbers which do indeed, if you look at it, add up to 42. So what we have literally written our own interpreter, right, which has its own language, which is it takes in all the numbers it gets until it reaches the end, at which point it prints out the number. So yes, you can run shell scripts written in anything you like, as long as they do that, right? Literally madness, right? Let's step back from the madness for a minute. So I said that part of what happens is the shebang is looked at when you tell the operating system to run the executable. This is actually a really cool mechanism in Linux that's a lot more extensible than you might imagine. So when you run an executable, for example, it can start a Linux binary, right? So that is literally what a file of the same type as intsum. Aha, that's a symbolic link, because of course it is. Right, so that's a 64-bit Linux executable. It can run shell scripts, because it can read, or anything that's a text file, because it can read the shebang. But it is, for example, extensible to run other types of binaries. Back in the days when Java was a thing that was not just for like weird web services and Android, some Java runtimes used to extend, put in some plugins into the operating system such that you could launch Java applications directly without invoking the Java bytecode interpreter. And it turns out this is actually true of modern Mono. So what is Mono? Mono is an open source re-implementation of the .NET framework, which is the common set of compilers and tools that Microsoft produces for producing platform-independent applications. Platform-independent, i.e. runs on Windows stuff. But one of the consequences of this is that you can compile and run applications that work on Windows, on Linux. So here I have what's the best way to show this off? If I just show this in Vim. Here I have written in Visual Basic, right? The same sort of Pi example that I've done in hundreds of other languages. This is written in Visual Basic. We can compile it on Linux. We can see what type of file it is. It's a Windows executable, right? So .NET assembly built for Windows. We can run it on Linux, right? We could execute this by putting the command in for the mono runtime, but actually as part of mono you get a little plugin to the operating system that says, I can also run this by running this on the mono runtime. I'm going to genuinely prove this is a Windows application, because that Windows machine I keep showing is a VirtualBox VM, so we can copy that to the shared folder, which is shared between the two machines. I'm going to do something here called checksum, called SHA-256sum, and that will generate a hash, so we can see that it's the same executable. It starts Abe 512 B 683 whatever, ends 4142, right? If we go over to Windows now, and I drag my mouse over, I open and I can copy that from Z, which is the drive that is shared. Right. It's now in there. I've written a batch file there. So one of the hidden features of Windows is you can use the tool it uses for validating certificates to generate the same type of hash as we just did. So what we can do now is I have broken that. How did I break that? See? I used too much Linux. I used the wrong slash. There you go. This is just a shell script, right? It's a batch file I wrote for Windows that runs certutil hash file pi.exe, whatever. We get the same hash out. See, 8512 blah de blah de blah 4142. It's the same executable. And it runs. We have just produced a binary that runs on Windows and Linux, right? And that's because the Linux side is running the mono runtime when it sees a .NET assembly, and Windows is running the .NET runtime when it sees the .NET assembly. Now, you might think this allows you to run lots of cool Windows applications on Linux, but it's actually a lot more difficult than that. There are a lot of libraries involved in running Windows applications you just don't have on Linux. They are closed source, they can't be put on there, although I know Valve is trying very hard with Proton to make this a thing, and it works very well, but it's not as easy as just installing mono and going. Anyway. So that was a nice aside. Job scripts. So why are we really telling our users about this? Well, it turns out that the way you interact with a HPC system, whether it's one of ours, or it's run by EPCC, it's Archer, or it's run by, I don't know, Cambridge, or Queen Mary, or King's, or whatever, almost always you'll interact with that HPC system through a thing called the batch scheduler. And a batch scheduler is a system whereby you package up your work into a job, you submit it with a list of resources you want to the scheduler, and when those resources are available, it runs. This is a process that is as old as computing, right? The very first batch schedulers was a literal person who took your punched cards, fed them into the machine, got the output, put it in the internal mail to send to you, and then moved on to the next task, right? So this is a very old mechanism. On our system, you use a set of commands which are part of a scheduler called Sun Grid Engine. The main command for submitting jobs is a job called qsub. And the reason we teach about shell scripts is because on our system and on most of these systems, a job script is just a shell script with some resource requests attached, right? So here we go. So if we want to look at a job script written in bash, right? We have a shebang. There's a small modification to the shebang on our system, which is that for a job script, you have to put a -l, right? That's because when your job is submitted, it runs through, the scheduler logs into one of the compute nodes, and then executes your job in a clean environment. And that means that you don't have a lot of the setup that is done when you normally log in, right? -l tells bash to act like a login shell, so it does all of that setup. So we have the shebang, we have some resource requests. I've asked for a gigabyte of RAM, 10 minutes of runtime, and to run in the current directory, and then it's just a shell script. In fact, these items can appear anywhere in the script because they are also, like the shebang, special comments. They start with a hash and a dollar. They are completely ignored by bash. Bash doesn't even really care that they're there. But when you run qsub reads those and treats them as if they were arguments you've given to qsub. You could give them on the command line, right? So if we submit that, right, we could just submit it directly and we get our information back. We could give other options. These things that I've talked about here are just options we could give on the command line. So we could say hash dollar dash n and then give it a name, or we can here say call it test2, right? As you can see, it's called it test2. These will run at some point, and we'll talk about the output when we get back. So, you might be thinking, I can submit a bash shell script as a job. Can I use any interpreter? And the answer is yes, with some caveats. So, as I said before, when the scheduler runs your script, it does it in a completely clean environment. That's why we tell you to put the -l in, so it acts as a login shell. And the main reason for this is that we provide a lot of software in our systems via a thing called environment modules, and for that to work properly, your login script has to source this file ect_profile.d modules.ship, right? If you run something that's not bash or is not a login shell, that has not happened. And so there's a bunch of setup that has not happened, and so your program will likely not work. However, you can do some of that setup as resource requests. For example, one of the very important variables to have set is a thing called ld_library path, which tells the operating system how to find the dynamically linked in libraries that are part of your program. Okay, and you can set that with one of the scheduler options, which is -v. So you can work around that one. And the other problem is your interpreter must ignore lines starting with a hash. So let's go back to the shell. Here we have a job script that works by using one of the Python interpreters we've installed. The shebang has the full path to the interpreter. We've set the load library path so it includes the Python runtime libraries directory and includes the libraries for GCC 492 that we built it with. So this is the special line that makes this work. Otherwise, it is exactly the same, right? They are commented out. You know, they've got the hash dollar, which says they're a grid engine thing, so Python ignores them because Python also treats hash as a comment. And then just say after that, it is just a Python script, right? We could put any Python in here, it would be fine. So we can submit that. Happily in the queue, right? We will get the output later. Can you use any executable? What about InSum? The sad truth is that yes, you can, right? As we've said, it just needs to follow those requirements. So yes, indeed, we do have it. I have written in here, oops, a job that is a grid engine job that runs through that little Fortran program. That really short Fortran program, right? It's what, 20 lines, 25 lines, something like that? Full job interpreter as far as this is concerned, right? You'll notice actually that I did, obviously this is very similar to the previous one. I have to include the GNU compiler libraries, but I don't need to include the Python ones because it's just a Fortran program, right? Submitted. Those are all in the queue, and I'll come back when they've run and prove that they all worked. Right, it is now sometime later and our jobs have all run, right? When we run qstat, it's empty, so let's have a look at the output. So the first, of course, is the simple bash job, and we hope that's worked. Otherwise something is very wrong with the universe. So if we have a look at the output file, let's grab this. You can see that it said hello from node, right? So this has worked, it's worked fine. The one whose name we changed probably has also worked fine, because it's just the same script, but with a different job name. Indeed it has. This ran on a different node, right? Node B00A006. So that's all cool. So that's the obvious things, and these are the things we teach users to do. Let's have a look at the Python job. Look at that, it ran. So you can write a job script that runs using any interpreter, Python, Perl, anything that behaves well in running shell scripts you can use to run a job, which makes us think that probably the insum job one has worked as well. And there we go, it's printed 42, right, which is the sum of those numbers. So you can do some truly stupid things, and I think that's kind of what I wanted to get to with this talk. If I just find my slides. Right, so in summary, the way your computer launches programs is interesting and lets you do some very dumb things. And I hope this has slightly increased your understanding of how these things work. There's a lot more to this, obviously, but this is very surface. This is what you need to know about how shell scripts behave. Please don't do the very adventurous or insane things on our HPC systems, or at least if you do, don't ask us for help. So if you shouldn't do it that way, of course, the obvious thing you should do is write your job scripts in the way we recommend. So how should you run a Python job? I'll write the job script here, but I won't actually submit it. Obviously, you should do it from within bash. You need to have your resource request as you would for bash. And then you should use the environment module system to bring Python into your environment and then run the script with that interpreter, right? So module load Python 3.9.10 and then run your script. Just as you would typing out the command line, right? Similarly with insum, you would just run that program in the script. Okay, good luck using our systems.